So remember, for parasympathetic innervation, the preganglionic origin comes from either brainstem levels associated with cranial nerves 3, 7, 9, or 10, right? Or sacral spinal cord levels, S2, 3, and 4. So preganglionics are either here in one of those 4 cranial nerves, or here, one of these 3 spinal nerves. But the distribution of parasympathetics is not nearly as complicated as sympathetics because parasympathetics do not go all over the body. Parasympathetics have a much more limited distribution. Nothing in the body wall receives parasympathetic innervation. Chest wall, abdominal wall, upper limb, lower limb, none of it gets any parasympathetic innervation. The total distribution of parasympathetics is to viscera in the thorax, viscera in the abdomen and pelvis, and some of the viscera in the head. And that's it. Okay? So that's what we have to get to. So let's tell the story by dividing it up into 2 halves. And the way we're going to divide it into 2 halves is to first take the cranial nerve 10, the vagus nerve, and combine it with the sacral, S2, 3, and 4. So that'll be one part of the story. Vagus nerve plus sacral, 2, 3, and 4. And then the other part of the story will be cranial nerves 3, 7, and 9. Now, the reason I'm combining the vagus nerve with the sacral nerves is because the way they innervate their end organs is exactly the same. In both cases, the preganglionic leaves the central nervous system and goes all the way to one of those terminal ganglia that we talked about. Remember, these are ganglia in the wall of an organ. They synapse on those terminal ganglia, and then the postganglionics innervate the end organs within those organs. Okay, so it's exactly the same pathway for the vagus as it is for S2, 3, and 4. The only thing that's different is where those organs are. So for the vagus, it's taking care of organs that are in the thorax and the upper part of the abdomen. And for S2, 3, and 4, which is also called the pelvic splanchnics, that takes care of organs that are in the lower abdomen and pelvic viscera. Okay? So the vagus nerve and the sacral and the pelvic splanchnic nerves, they sort of divide up the body. Vagus takes care of thorax and upper abdominal viscera. Pelvic splanchnics take care of lower abdominal and pelvic viscera, and that's it. That takes care of all of that parasympathetic innervation. So that now just leaves us with the head to deal with. So the head is going to be the responsibility, parasympathetic responsibility of cranial nerves 3, 7, and 9. Not 10. Because 10, even though it's a cranial nerve, its region of distribution for parasympathetics is thorax and abdomen. So 3, 7, and 9 take care of the head. And the way they do that is different from what we described here. We do not have terminal ganglia. The postganglionics are not in the wall of the organ, but rather there are specific, discrete ganglia, 4 parasympathetic ganglia that are found in the head, in different regions of the head. A ciliary ganglion, which is in the orbit, a submandibular ganglion, which is in the floor of the mouth, a pterygopalatine ganglion, which is in the pterygopalatine fossa, and an otic ganglion, which is in the infratemporal fossa. So 4 different ganglia in 4 different parts of the head. And the way these 3 cranial nerves get to those ganglia is fairly specific. Cranial nerve 3, all of its preganglionic synapse in the ciliary ganglion. No exceptions. Cranial nerve 9, all of its preganglionic parasympathetic synapse in the otic ganglion. No exceptions. And then cranial nerve 7, its preganglionic synapse in one of the other 2 ganglia by way of 2 different branches of cranial nerve 7. So for the preganglionics in cranial nerve 7, the facial nerve, they either synapse in the submandibular ganglion or in the pterygopalatine ganglion. Okay, so that's the preganglionic part of the story. And then the postganglionic part of the story is that from those ganglia, postganglionics go to their end organs. And there aren't a lot of end organs to deal with. For the ciliary ganglion, postganglionics innervate just 2 end organs. The sphincter pupillae for constricting the pupil, and the ciliary muscle for controlling the shape of the lens. 2 different smooth muscles. So that parasympathetic pathway is third nerve to ciliary ganglion to pupillary, sphincter pupillae, and ciliary muscle. That's it. For the otic ganglion, all of those postganglionics go one place and one place only, the parotid gland. So the parasympathetic pathway to the parotid gland is 9th nerve to otic ganglion to parotid gland. That's it. For the submandibular ganglion, all of its postganglionics go to one of the 2 salivary glands in the floor of the mouth, submandibular or sublingual gland. That's it, all of it. So the pathway for those 2 salivary glands is 7th nerve to submandibular ganglion to those glands. And then finally, the pterygopalatine ganglion takes care of everything else in the head that needs parasympathetic innervation. And what everything else in the head means is the lacrimal gland and all of the glands of all of the mucosal surfaces in the head. Nasal mucosa, oral mucosa, pharyngeal mucosa, paranasal sinus mucosa. Any place where we have a mucosa in the head, that mucosa receives its parasympathetic innervation, postganglionic parasympathetics from the pterygopalatine ganglion. And the lacrimal gland does too. So the pathway for that is cranial nerve 7 to pterygopalatine ganglion, and then pterygopalatine ganglion to the end organs. That's it. So that's the totality of parasympathetic innervation. That's the end of the story. So what we said we wanted to accomplish in this section was to identify the anatomy of the vertebral column and spinal nerves, and we did that. We talked about the lumbar puncture, and we talked about intervertebral discs. We wanted to understand the difference between somatic and autonomic nervous systems, and we wanted to understand the differences in the pathways for sympathetic and parasympathetic neurons, which we did.